Hi, I'm Shauna, and welcome to our series on troubleshooting automated industrial systems. We have been talking about an approach to troubleshooting, and this is the first step that we looked at in the previous video of the overview of our approach. The first step is observing an indication of a system upset. So we're actually reviewing how we would find different problems within the system. Most automated systems are now run on SCADA or DCS, and as a technician you would be sitting in front of a board or a set of monitors, computers, and you'd also likely be out, if you're on site, out in the field with the equipment itself, working on maintaining and operating that equipment, getting familiar with it, and then also you would be able to see the equipment. So these are the three ways that we could actually observe a system upset or a problem, is by the data or information that's coming across on the board or the monitor for us. Also just being familiar with the equipment, and then visually observing the facility itself. Here we're looking at an example of a process flow diagram screen on a DCS system for a natural gas processing plant. I'm going to flip back and forth a little between this screen and some other parameters, but basically this is what you would be watching and showing the operations in this facility. So if we're watching the board or the monitoring screens that we've seen pictures of, these are the type of alarms that we might see as an indication of a problem. In the programs of the DCS or the SCADA, there are pre-programmed set points for optimal system performance, and anytime the facility or system is outside of this range, there will be alarms to indicate that the performance is not optimal. Now, there could be various levels or priorities of alarms as well, and those can be, for example, there might be a high level indicator, a high, and a kill. And so the operator would know the different priorities of those alarms and maybe be able to make some decisions based on that information. The first thing generally that happens in this system is there's an audible alarm that gives you the first clue to severity. There may be, it depends on how it's programmed, there may be a ding or multiple dings or a buzz or a siren or other pre-programmed alerts that you would know based on your own system. Then you'll know to look at the data points on the alarm screen and then back at the process flow diagram that we looked at previously to gather more information about the problem or the system upset that's happened. This is the example of the PFD screen that I had just put up previously, and we would be watching this for any changes or alerts in the system. This is actually just a very small portion of this facility, whereas the dry gas dust filter temperature outlet to the exchanger, and there are some different temperature indicators here. Here we're looking at an alarm screen for that actual location in the process flow diagram that we had seen before. And this is the first part, an audible alarm, a ding would sound, and then the alarm here comes up. It tells us that it's the demethanizer. This is the source tag related back to the location on the PFD when we flip back to find more information there. The condition here, this is the alarm, PV high. We talked about there could be a high, a kill, or any other pre-programmed condition, and so you would know this from knowing your specific facility. This is the information. Now, this is the trip value, and this is a temperature. Here is the value. That means that's a value that was out of spec when this alarm occurred, which is time-stamped. Now, the operator was watching, and the current live value, we can see, is here. It's changing. So this actually went back down within 6 seconds, went back down within the normal range. If the trip value was 95 degrees Fahrenheit, that's a high value because we know PV high. and this number, the live value, was still climbing, that would be an indication of an additional problem that is occurring. Now this value 6 seconds later is back down within spec, and so that might indicate something else to the operator. In this instance, dropping back down could be just an issue, a blip in the transmitter, and so the operator would continue to watch this and see if there's any further action necessary. Just to review what we had just talked about on that alarm screen, it alarmed at 95 degrees Fahrenheit, which was the pre-programmed alarm point where the system is out of spec, but then 6 seconds later it's flowing back at 83 degrees, back within the specifications of the system. So the operator can stop and think that a 12-degree increase within 6 seconds and then back into spec could just be a transmitter error. And then again, I pointed out if we saw that a different scenario where that number was actually increasing within our alarm and showing real-time data, then we may have a different problem that needs to be dealt with. The top screen here, we looked at the bottom screen as the alarm. The top screen, each operator can individually choose on this specific system. Each operator could individually choose the different data that they'd like to monitor during their shift, which they've learned to show them specifically what might indicate errors or different system problems. And so this operator is monitoring these different specifications here and looking for changes, abrupt changes, slow changes that are happening within this data. We talked about the high temperature alarm on that previous screen, and so once that alarm comes up on the screen, then you as the operator can flip back into your process flow diagram, and there's a point, we talked about that number, the tag number. Now this is the tag number that relates to the alarm screen, and here in this specific system, the triangle indicates which point alarmed, and then we have the live value of 83.3. So taking this information together, both screens would give you as an operator some indication of the problem that's occurring and where it's at. We can see the flow lines here coming in from the gas dehy and then going this direction through the valves, and so we can see that for some reason it was coming through and the temperature here increased. Now we previously decided because this dropped back down that it may be an issue with the transmitter. If it was still climbing, we may have an issue with the gas leaving the dehydration unit that's causing the gas to be too hot. So the second way that we might observe some system upsets or problems with the system or the equipment is actually direct observation of the equipment. If you're on site in the plant, you should be familiar with the operating conditions of the equipment, out just monitoring regular everyday equipment use, maintenance, operations, and know how that equipment operates. It's kind of like your car. When you're driving your car, you just get used to the noises and the clicks and clacks that happen. When something starts squealing, you know there's definitely something wrong. This is the same for each individual piece of equipment that you're responsible for in a facility. And one big indicator always is noises. Equipment makes noises, it's loud, that happens, but there is a normal noise that happens, and then when the noise changes or there's a different noise, a clack or a squeal or a vibration or a banging or anything that can indicate a problem. And then vibrations are a big one. It can start vibrating differently or just really loud, just indicating there's a problem. In any plant that's working, especially like a cryo plant, you could start having ice or frost on the equipment indicating some kind of problem, or you may actually see a temperature change differently as smoke, steam, or exhaust. And those are all ways that you may observe issues in the plant. Of course, you need to be out there regularly getting familiar with your equipment before something goes wrong so that you do know when there is a change. And the third way I spoke about earlier was remote observation of the equipment or the system, and that's actually usually a visual observation. You can be in the plant, you could be driving up to the plant to work, you could be actually monitoring the facility with cameras. When that alarm goes off, some people might also check right away the cameras or just look out the window depending on where your location is. And there may be noises that you can hear or things you can see, smoke, steam, flames coming out of the plant. Of course, this is like a major problem, but there could just be an issue where you look out or you drive up for your shift and the flare's going like crazy, and you know that they've had a system upset or something different is happening. If you're at a water treatment plant, you may see a change in the depth or flow rates through the channels or different reaction chambers, and that would also give you an indication of a problem in the system. This concludes the step of observing an indication of a system upset or a problem to start off the troubleshooting approach that we've been overviewing. If you're working on an automated system, it frequently sends system performance information and collects real-time data for you to look at through either a SCADA or DCS system. The PLCs interact with the SCADA and DCS to send the information and operate the equipment. And then there's the direct observation of the equipment or system from being from the hands-on work, being at the plant or the facility and being with the equipment. And then again, we talked about the remote observation, mostly visual observation when you can look at the equipment or the plant itself, or through cameras that you have on the full facility or different equipment within the plant. And I know this is happens very quickly, but this is actually the first step, is observing what something happening or a change or a system upset. And then the next step we go on to is trying to figure out what the actual problem is and the responses to that problem. So this is just the second in the series, the first step in the troubleshooting. Thanks for watching. I hope you follow along as we learn together about troubleshooting automated industrial systems and a good overview of the approach.